Hello children, welcome to another lesson on SBC television. I am Mr. Dave Gopaul from English River Secondary Schools. The science lesson I've chosen for you today is about lenses. These are your objectives, the lesson objectives. Read it. Extended candidates. On top of what the previous slide, you have to know these ones also. Draw and use ray diagrams, describe the use of single lens as magnifying glass, etc. Now, what is a lens? A lens is a piece of glass or plastic. You do have plastic lenses also, which refracts light in a predictable and useful way. You can refract light the way you want it by designing your lens. You have got two main types of lenses. You have got the convex lens and the concave lens. The convex lens is thicker in the middle. The concave lens is thinner in the middle. We will be studying only this convex lens. Convex lenses are also called converging lens because when rays go through it, these rays, they converge, they come together. Whereas concave lenses, they are called diverging lens because when rays go through it, these rays move away, they get diverged. Therefore, convex lens, another word for it is converging lens. It is thickest in the center and it bends light inwards. It brings them together. Right? Concave lens is contrary to the convex lens. It is a diverging lens. It is thinnest in the center and it spreads light out. We are not going to concentrate on this one. It is not in your program. Now, this is the anatomy of a lens. You have seen a lens, just a piece of glass, but there are certain things that are very important for you to know. They are just imaginary points. The principal axis is an imaginary line that is drawn at right angle to the optical center, to the center of the lens. This principal axis. Then there are 2 points that are very important. It is a focal point. I am putting the focal point on both sides of the lens because you can be using the lens on both sides. You can be using the lens from here to look for something over there, or you can put your eye here to look for something here. Therefore, if I put F here, which is a focal point, I can have F on the other side also. Another point which is also important is that twice the focal point, 2F. And the distance between the center of the lens and the focal point is called focal length. Look at it again. This is only what you know. But when it comes to predicting size of image, position of image, whatever, you will need these references: principal axis, horizontal line, go at right angle to the optical center, to the lens, the focal points, F on both sides, 2F on both sides. The focal point is also called principal focus, and the distance between the optical center and the focal point is called the focal length. Center of lens, optical center C, line through C at right angle, principal axis, the principal focus F, you will see it later. This is a point through which all rays close to and parallel to the principal axis, they converge on leaving the lens after refraction, and the focal length distance between the optical center principal focus. Again, if you put meaning to these sentences, you bring it here, you will be able to know what we mean. Optical center, principal axis, line through the optical center at right angle to the lens. Principal focus, it is a ray of light which is close to the principal axis. When the ray of light leaves the lens, it will have to go through F. Okay, you will learn this in the forthcoming slides. Huh? So, here. Now, when you are trying to position an image of an object through the lens, there are two or three important lines that you have to draw. One is a ray of light which is parallel to the principal axis. As I said earlier, it will be refracted through F. This line will have to go through F. Another ray of light which is going through the optical center, this one will not be deviated. It will go straight through. These two lines are very important. Parallel to principal axis, deviated through the principal focus, lines through the optical center which is undeviated. And where they meet, this is a point here. This point will appear here. So this arrow will be upside down on the other side and is going to be bigger also. This third line is optional, and you can see this third one is a contrary to the first one, to the green one. Here, the ray of light is going parallel to the principal axis, therefore it is deviated through the principal focus. Here, the ray of light is going through the principal focus, therefore it will run parallel to the principal focus on the other side, the contrary of the first one. Right? Now, first rule in drawing, in positioning your image. Ray of light parallel to principal axis. On refraction, passes through the focal point. Ray of light parallel to the principal axis. On refraction, passes through the focal point. This, it has to go through F. First rule. Second rule. Ray of light passing through the optical center goes undeviated along the same path. Ray of light going through the optical center, it goes undeviated. It goes straight through. The third rule, which is the inverse of the first rule, when a ray of light passes through the principal focus, it is refracted parallel to the principal axis, the contrary of the first one. Parallel through F, parallel. Only three lines. You will use only two of them in any case. We move. Now, here again, when you are drawing, positioning images, it is important that you use squared paper or graph paper because you have to be precise. So first thing you do, you draw your lens and you draw your principal axis. Very important. And then you position your F. And remember, you will have F on both sides. You can also put 2F. If this is 1, 2, 3, 4, 5 squared away from the optical center, so the F is here. Another 5 squared, you have 2F. 5 squared on the left, F. Then another 5 squared is going to be 2F. I hope I'm making myself clear. You draw your lens on the squared paper, draw your principal axis, write F, 2F, repeat it on the other side, F and 2F. Your object is just going to be an arrow resting on the principal axis. Not too big, not bigger than the lens. Okay? Your arrow is here. Then you draw a line from the extremity of the arrow, a line going to the optical center which goes straight through. Another line parallel, this one will have to go through F. That was your first line, that is your second line. And where do they meet? Here. When they meet here, it means that this tip will appear here. And this is going to be your image of this object behind the lens, where the rays meet. So, position your lens, draw your principal axis, position your F to F, draw your image, your object, and then draw your rays, one through the optical center, one parallel, where the two rays meet, it is where this point is going to be. And this is going to be your image. Simple drawing ray diagram using for the lens. Now, I want you practice this at home. Just 3 steps I gave you. You will try to draw images, the image position of an object placed in the following ways. Beyond 2F, 2F, between F and 2F, less than 2F. What do I mean? Beyond 2F something, so you put your image here. And then you draw, you see where is going to be the position of your image. What did I say? Image, you put your object here, and you see the position of your image on the other side. So, beyond 2F. You will draw another diagram when you put your object on 2F. Again, same things. One line through the optical center and deviated, parallel, deviated through F. You will see the position of the image when the object is placed at 2F. This is a second instance. Then you will draw another diagram with an object put between 2F and F, somewhere here, anywhere, between the 2F and the F. The third diagram, and another diagram when you put an object between F and the optical center, somewhere here. Image position on object placed in the following ways: beyond 2F, 2F, between F and 2F, less than F. And you describe the nature of the image. If you do it, again, beyond 2F, 2F, between F and 2F, less than F. You will see that in some cases, you will be using these words, real and virtual image. Virtual image, we met it in when doing mirrors. Your image in a mirror cannot be produced on a screen. If you go behind your mirror to look at you, you cannot see yourself because it is not there, it is not real, it is virtual, right? But real images can be formed on a screen. Virtual images cannot, right? You will have to be. Now, let us look at this. An object placed at a distance beyond 2F. When the object is beyond 2F, when you draw your lines, you will see that the image is going to be between F and 2F. And it is going to be smaller. And it is going to be inverted. Let us see if we understand it well. Image is between F and 2F. It is real. You can produce on a screen. it is even inverted upside down, and it is diminished, it is smaller. When you draw it at home, you will see these things. This is for an object placed beyond 2f, between f and 2f. Real, inverted, diminished. When you put your object at 2f, your image will fall exactly at 2f. It's again real, it is inverted, and this time it is of the same size. Do it, draw it at home, you will see it. When you put your object between 2f and f, this time your image is going to be beyond 2f. It is going to be magnified, it is going to be bigger, inverted, real. And when you put your object less than f, you will see that these lines cannot meet. Lines cannot meet. So, they will meet on the same side as the object is. You produce the lines, and this is where they meet. On the same side as the object, and it's going to be magnified, upright. It's not upside down here, it is upright. It is magnified, and it is virtual. It cannot be produced on a screen. And here, you are using the lens as a magnifying glass to make something look bigger. So you have to understand this. When an object is beyond 2f, the image is between f and 2f. When the object is on 2f, the image is on 2f. When the object is between f and 2f, the image is beyond 2f. When the object is less than f, you cannot have it on the other side. The ray will not meet. The rays will meet on the same side as the object. You are using your lens as a magnifying glass. Draw these rays, the 4 diagram, and you will see what I've just said. Now, when you draw your diagrams, your rays, which is or correctly refracted. This one has a ray of light going straight through the lens and then is refracted on leaving the lens. This one is going, it refracts a little and then refracts again. This one is going straight to the mid-vertical line and then is refracted. This line is going up to the other edge of the lens and then is refracted. This one, it starts refracting as it enters the lens and then it refracts again. This one is going straight to the midline and then is refracted. Which one or which is or are correct? Now, the first one is wrong. The first one is wrong. It is refract. The second one is fully correct because as the ray enters a denser medium, it is refracted. When it leaves the medium, it is refracted again. You learned it earlier. It's a glass block. So this one is fully correct. Refracted, refracted. And you get full marks drawing rays like this in your exams. But we do accept the ray of light going up to the mid-vertical line and then getting refracted. So these two, this one is fully correct, but in an examination, even if you start refracting your ray from the mid-vertical line, you will get your mark. But if you saw your refraction from the edge of the lens, you will not get marks. Therefore, be careful about this one when you are drawing your rays. And the same thing applies to the prism. As you know, when the ray of light goes, it doesn't go straight, it gets refracted, and then the rays get split. We studied it earlier. The ray of light does not go straight, it gets split. And then this is a dispersion of light, right? Let us consolidate what we have just been learning by trying to attempt some questions. In the diagram, the distance OP is a focal length of the converging lens. One ray of light from O is shown. Through which point will this ray pass after refraction by the lens? This ray going from F here, is it going to go through A, through B, through D, or through C? The answer is A. Why? Because this ray is coming from F. When it is coming from F, it will have to go parallel to the principal axis. The same way, if you're going parallel to the principal axis, it will be refracted towards F or through F. But if it is coming from F, then it will go parallel. You remember 3 lines I gave you earlier? One going parallel through F, going to the optical center, and one going through the F will go parallel to the principal axis. Therefore, the answer is A. Look at this one. A lens forms a blurred image of an object on a screen. You can see why. This is a screen, this is object, the image is blurred because it is not focused. The point is not meeting. Now, how can the image be focused on the screen? Is it by moving the object away from the lens, moving the object away? Do you think by moving the object away, this point will fall on the screen? No way. Do you think by moving the screen away from the lens, the screen should be here. If you move it away from the lens, you are going to focus the object? Nonsense. No way. Do you think by using a brighter object at the same position, the problem is not the amount of light, it is about the position of the object and the position of the screen. Therefore, this one also is wrong. So, we are left with option D. Let us see what it means. By using a lens of longer focal length at the same position. So, if you use a lens of longer focal length, then you will be able to focus, to bring the object into focus on the screen, because here is the focal length. So, the object okay, I hope I made myself clear. Using a lens of longer focal length at the same position, then the image is going to be on the screen. Convex lenses are used in cameras and as magnifying glasses. Which type of image or form? Now, in cameras, the image is real. In magnifying glass, the image is not real, it's virtual. We said it earlier. Look at option B. Camera, image is real. Option B is correct. In a camera, you do have the image, the real image. So, the answer is B. Again, which label distance is the focal length of the lens? Okay. But the distance cannot be A. Wrong. Let us look at B. Parallel to principal axis, parallel, okay, and the distance between F and midline here. Therefore, the answer is B. It cannot be C because this is wrong. It should not be going, it cannot start from F and go through F. It will have to go parallel, and this one is parallel. It will have to go through F, okay, but the distance will be from here to here, not from, and not the distance between the two edges of the lens. I hope you got this, huh? So the answer here is B. Points labeled F or principal foci of a lens, F. A beam of parallel light is incident on the lens. You have got light parallel to the lens. Okay. Which diagram shows the path of the light after it passes through the lens? So, this is wrong. It has to go through F. A is wrong. Let us look at this one. It has to go through F. C is wrong. Let us look at B. It goes through F. So B is correct. The rays of light parallel to the principal axis has to go through F. Right? Here, which diagram correctly shows rays passing through a camera lens? Okay, this is the object. So, the rays cannot be refracted before reaching the lens. So, A is completely wrong. Let us look here. This ray of light, it goes to the optical center. Therefore, it goes undeviated. So, this one is correct. Until now, this one is correct. Here, the ray cannot just go straight through the lens like this. It will have to be refracted. This one is wrong. Only when it goes to the optical center, it goes straight. Therefore, this one is wrong, and this one also is wrong. Okay? The image here is of this is vertical, is not even upside down, etc. So B is the correct answer. Look at this one. This is your object. Ray of light going to the optical center and deviated. Parallel going through F. What is the focal length of this lens? Focal length is going to be where the ray meets the principal axis. Therefore, it is here. So, the focal length is going to be 10 centimeters. The distance between the F is here. The lens has to go through F. The F and here, this will give you the focal length. I know it's not easy to grab it, but you will forget it. You have to read through your books. Try to see what is happening. It's not that difficult. Answer is B. Okay? Only 3 lines I gave you to learn. Parallel through F, through the center and deviated. The other one, if it goes through F, it goes parallel. So, in essence, you have got 2 lines. B, look at this one. 2 thin converging lenses are used, are shown to give a focus image of an illuminated slit. Now, what is the focal length? If this ray of light is going parallel here, if it is going parallel, therefore, what is the focal length of X? It will have to be 30 centimeters, no? The answer will have to be C or B. Let us look here. Here it is parallel and then it is going through this distance. Therefore, this is a focal length. When it goes parallel, it goes through F. Therefore, it has to be 30 and 15. 30 is okay. Here, 15 is okay. Therefore, it is C. Again, how the rays behave when going through the lens. If it is coming from F, it will go parallel. If it is going parallel, it will have to go through F. And the distance between the midline and F is focal length. Therefore, 15 is focal length for Y, and 30 is focal length for X. Answer is C. This one, path of a ray of light passing through the principal focus F. Where will it go? Parallel, B. Through F, it will go B. If it goes parallel, it goes through F. Right? Look at this one. 3 rays, converging lens, each point labeled F, right? Now, which of the rays are drawn correctly? Let us look at this one, ray X. It goes through F, correct. This ray Y, it goes undeviated, correct. This one ray, it goes through F, it should be going parallel, not like this. Therefore, F is wrong. So, which rays are correct? I have said X and Y are correct. This one is wrong. No, X and Y means C. Another question. Object is placed in front of a thin converging lens. Okay, the image of the object on the screen is on the right of the lens. Yes, the line cannot be meeting. Therefore, how does the image compare with the object? Right? Okay, the image of the object is formed on a screen to the right of the lens. Therefore, the image is going to be formed here. So, the line if you produce is going to meet. So, you can see if this line is produced and they meet, they are going to be larger. We have to go on the wall, it has to be larger. And it will be upside down. Therefore, A is the answer. Okay? A ray of light. Arrête un petit peu. Encore, nous parlons trop beaucoup, il peut être fatigant, nous caves. Et nous finissons aussi là. Allez, on recommence. Okay. We've come to an end of this lesson. I've tried to bring you some questions just to reinforce what I've been teaching you. Remember, there are only 3 rays that you have to master. The ray of light, parallel to the principal axis going through F, ray going to the optical center and deviated, or a ray of light going to the F, then it goes parallel to the principal axis. And just focus on these 3 rays. You will be able to answer many of the questions. And I would advise you again, read your books, try to attempt as many questions as you can, and contact your teacher if you need help. Thank you for this lesson.